So have you heard the buzz lately? I mean, there's this programming language that's kind of been taking the tech world by storm, and today we're going to figure out exactly why. All right, let's dive right in.
Okay, get this. For 8 years in a row, the Stack Overflow Developer Survey has been saying the same thing loud and clear. We're talking over 86% of developers who've actually used Rust. Well, they don't just like it, they absolutely love it and want to keep using it. That's not a trend, folks. That's a full-blown movement.
And this isn't just some niche thing for hardcore coders. The conversation has gone all the way to the top. I mean, when the White House itself puts out a report talking about cybersecurity and specifically calls for a switch to memory-safe languages, and then names Rust as a prime example, yeah, you know something big is going on.
So that really brings us to the big question, right? What's the secret here? Why is everyone so hyped? What makes this language so special that everyone from individual developers to huge corporations and even governments are paying attention?
All right, to really get Rust, we first have to rewind a bit and talk about a huge problem that's been bugging programmers for decades. It's what I like to call the programmer's dilemma.
So, for the longest time, developers had to make this really tough choice. On one side, you had these high-level languages like Python or Java. They're super safe with memory because they have something called a garbage collector doing all the cleanup for you. But the catch? That safety costs you in performance. Then, on the other side, you've got languages like C and C++. These things are fast, blazingly fast, but you're managing all the memory yourself, which means there's a huge risk of creating these nasty, hard-to-fix memory bugs.
So that's the bottom line. You had to choose. Did you want speed or did you want safety? Getting both at the same time, well, that was the holy grail. The thing everyone wanted, but nobody thought was actually possible.
And then, Rust came along, and it completely changed the game with this totally new idea. It's called ownership, and believe me, it's a whole new way of thinking about how code works.
It all boils down to 3 rules. They sound simple, but they are incredibly powerful. Rule 1. Every single value in Rust has a variable that we call its owner. Rule 2. There can only be one owner at a time. No sharing. And Rule 3, when that owner is done, like when a function ends, the value it owns gets dropped automatically. Poof! Memory freed up.
Okay, so who makes sure everyone follows these rules? That's the job of Rust's secret weapon, the borrow checker. The best way to think about it is like a super strict but also super helpful teacher. It's part of the compiler, and it checks all your work before the program can even run, making absolutely sure you haven't broken any of the memory rules. And this is designed to prevent some of the scariest bugs out there, like a data race. Just think about it. That's a nightmare scenario, where you have different parts of your program trying to access and change the same piece of memory at the exact same time. It leads to chaos, corrupted data, you name it. The borrow checker just makes that whole class of bugs totally impossible in safe Rust. Gone.
And by being so strict about this stuff, Rust finally does it. It delivers on that holy grail we were talking about.
This right here, this is the big aha moment, because the borrow checker does all this work at compile time. That is, before you run the program. Rust doesn't need a garbage collector running in the background slowing things down. All the memory safety is guaranteed and just baked right into the final code.
And that's it. That's the solution to the big dilemma. You get the screaming fast, bare metal performance of something like C++, but you also get the rock-solid safety guarantees of a language like Java. It's literally the best of both worlds.
So, what does all this mean for the real world, for developers, and for the tech industry? Well, it means the future is looking pretty rusty.
Now, let's be real for a second. It's not all sunshine and rainbows. Rust is famous for its learning curve. People talk about wrestling with the borrow checker, and it's true. It forces you to think in a new way. But here's the thing. Almost every developer who sticks with it talks about this amazing aha moment when it all just clicks into place. And they say it makes them a better programmer, period.
And hey, getting through that learning curve really pays off. We're talking cash. The demand for Rust developers is so hot right now that they're seeing a salary premium of around 15 to 20% compared to similar jobs. The market wants these skills, and it's willing to pay for them.
And just look at who's building with Rust. We're not talking about small startups here. We're talking about the absolute titans of tech. Microsoft, Amazon, Google, Meta, Dropbox, Discord. They are all betting on Rust for some of their most critical systems, the stuff that needs to be both incredibly fast and incredibly secure.
So that kind of brings us to a final, pretty important thought. Our entire world basically runs on software now, from banking to the power grid, everything. And so many of the security holes we hear about come from simple memory bugs. So the real question is, in today's world, can we really afford to treat memory safety like it's just some optional feature?